So let's take a look at template issues. Why? Because templates are very fragile and they can and often do fail. And when they fail in just amazing, disastrous consequences happen in your application, and you're often left struggling trying to figure out what's going on here. So a lot of instructors like to paint a rosy picture like these are perfect, and they are anything but. If you want bugs in your app, use templates. So I'm not going to try and dissuade you. They're very powerful and they have their place, but a lot of times you're going to have a lot of problems if you can't figure out what you're doing. Anyways, so we're going to make a templated function. We're going to start with the template keyword, and I'm going to say class T, comma, class F. You may be going, now wait a minute. Didn't you use something different in the previous videos? Yes, I did. I used type name. Now, this is the other confusing bit. Keywords, type name, and class are used virtually interchangeably. There are some subtle differences, and you as the programmer will often not notice those differences. But at the very end of this, all the way at the end, here we go. There's one exception where you have to use class and not type name when declaring a template. For example, if you're going to use a class, that's why it's called class. So I almost always use class just because they are used virtually interchangeably. And if you're going to use a class, use class. Now, a lot of people, especially in the Q&A section, are going to fire off a lot of, no, you're wrong, this is what you should do instead. And in some cases, they're probably right. Again, based off the documentation and based off a lot of the majority of the answers out there, they're used virtually interchangeably. But I almost always use class. So a lot of people are going to say they're equivalent. A lot of people are going to say they're different. But at the end of the day, they both usually just work. All right, so let's go ahead and say we're going to return T using a function called add. And this is going to look just bananas, but bear with me here. Value 1, comma, and then data type of F, value 2. Notice I said data type of F. So what we're doing here is we're saying, hey, we're going to use two different data types, a T and an F, and they're both going to be classes of some kind. And we're going to make a function called add. It's going to return the value type of T, whatever we give it, but we're going to add T and F. That sounds really super confusing. And now you know why templates suck. I'm sorry, I'm just going to say it. Because it gets very confusing and you can break things very, very quickly. So return, and we're going to simply return value 1. And let's name this value 2, just so we can... Actually, let's name it value F and value T. Ah, super, super high tech here. So we're just simply adding two values and then returning it as T. Notice what we're not doing. We're not doing any type of casting. We're not even attempting to make sure that is a valid value of any way, shape, or form. But if we save and build, this will build, and you'll have 0 warnings, 0 problems, 0 issues. It just thinks this is perfect. Oh boy. All right, so fasten your seatbelts here. This is what we're going to do. We're going to say QInfo, and let's go ahead and add. And we want to add an int. Let's see if I can get rid of those little yellow things. An int and a double. Now, because this is a template, we have to do it a special way. We need to tell it anything in the brackets. Remember, these brackets, we want replaced with whatever we type. So we want to tell it, I want an int and I want a double. So we have two different types here, T and F. So I'm going to say my T is an int, my F is a double. Now I can actually work with it. I'm going to say 1, and let's go ahead and add it to 4.6. All right. So what we're doing here is we are telling C++ what to do. We're explicitly casting this. We're saying explicitly cast it C++, do it for us. Which of course, if we're telling C++ to do it, is an implicit cast, which gets very, very confusing. But when we run, yes, it's a 5. Or is it? Well, what's happened here is we're saying 1 plus 4.6. If you add those two together, it's really 5.6. But of course, we want it to return a T, in this case, the first one, which is an int. So it's going to implicitly cast it down to a 5 instead of a 5.6. That is super frustrating. You might not have wanted that answer. Okay, so that is a subtle bug right there. Now, let's take this guy and let's change this. So I'm going to say, let's get rid of this. I don't like that. Let's just get rid of it. And I'm going to say 55 and true. Notice what we're not doing. We're not telling it what to do. This is bad. This is bad for a multitude of reasons because we are telling C++, hey, here's two values, just figure it out. And if we build this, drum roll, it builds. That is scary. And we can run this and we get 56. Wait, what? 56? We're saying 55 plus true. The computer equivalent of true is a 1, so it is converting that into a 56. Oh, that is super frustrating. Now, what happens if we grab this? Notice we're not telling it the data types, and we just simply flip those around. We're going to give it a true and a 55. What is it going to return? Well, we're telling the first data type is a bool, so it's going to return a true or a false. So now the order suddenly matters. It's returning true because it's not 0. Oh, that is scary. So the same data is going to give you two different results. And unfortunately, it gets way worse than that. Let's go ahead and do this. And we're going to say add 55 to true. Nope. Wait, what? What's going on here? Cannot initialize return object of int with an R value of const char point. So what's going on here is we are now telling the computer, hey, add this number to this character pointer. This is super confusing. Everything's worked, but now this doesn't work because we're trying to add two different types. And if we try to build it, okay, there you have it right here. Cannot initialize a return object type of int with an R value type of const char pointer. All right. Well, let's try the opposite here. Let's try, and I'm going to actually change that to my name so no one thinks that's a bool. Let's try this. See what it does. It actually builds, even though you really cannot add a string to an integer. Watch what happens. We get this thing right here. Where the heck did this even come from? Q-byte array. What? Do you see the problem here? You're going to get some just radically unpredictable results if you get it working, and you really can't trust it. So, major takeaway from this is it is extremely powerful, but at the same time, you have to be very, very careful because you can get some just crazy information back from this, even though it compiles and it says there are no issues. So, buyer beware. Always, always, always declare your data types and make sure you understand what you're doing.